On this page we're going to be looking at adding and subtracting algebraic expressions. Another way of saying it is collecting of like terms or simplifying algebraic expressions. Now what we mean by like terms are those terms that have exactly the same pronumerals in them taken to the same powers. So for instance, if we're asked to simplify 5x minus 2y minus 3x plus 7y, we can gather up the like terms, which are the 5x and the negative 3x. So 5x subtract 3x is 2x, and then looking at the y terms, which are alike, negative 2y plus 7y, they have the same pronumerals and taken to the same power of 1, so negative 2y plus 7y is plus 5y. We could have actually written it in this way. We could have said the original expression was this, so I've rewritten it. Then I could have collected up the 5x minus 3x and the negative 2y plus 7y, so the like terms are close to each other, and then done the final simplification. 5x minus 3x is 2x, negative y plus 7y is plus 5y. Remember that the sign in the algebraic expression belongs to the term after it. So for instance, we're looking at negative 2y as having a coefficient of negative 2, so the negative sign belongs to the 2, and for negative 3x the coefficient is negative 3, the negative sign belongs to the negative 3. Let's have a look at our next problem. 5x plus xy minus 2xy plus 7x. Let's gather up the terms that are alike. We've got x terms, 5x plus 7x, so we get them close together. Then we've got xy minus 2xy. Gathering up the x terms, 5x plus 7x is 12x. And then gathering up the xy terms, plus xy minus 2xy, the answer is negative 1xy, so just negative xy. For the next one, we've got an x squared term there and there, so we can gather those up. We've got a y term there and another y term there. We don't have any other xy terms except that one, and no other x terms except that one. So let's just gather up the like terms first. So we've got 5x squared minus 2x squared. We've got rid of those two. Then gathering up the other like terms, which were the y terms, plus 2y minus y. So we've got rid of that one and that one. And we're left with plus 6xy. Notice there are no other xy terms. And plus 2x. There's also no other x terms. Now simplifying. Like terms, 5x squared subtract 2x squared is 3x squared. 2y minus y is 1y, or just y, so plus y. Now because we can't add or subtract any other xy terms, we've just got plus 6xy plus 2x. So that's as simple as we can make that particular expression. Moving on to the next one. That starts to get a little more difficult. So let's have a look. We've got an x squared term there. Do we have any other x squared terms? There's one there. Okay, so let's write those in, so gather them up. Negative 8x squared plus 9x squared. I got rid of those two. The other terms we've had, the next term is 6x cubed. Are there any other cubed terms, x cubed terms? Yes, there. Okay, so let's write those in. So plus 6x cubed minus x cubed. I've got rid of that one and that one. And the other terms that are now left are plus xy minus xy. So plus xy minus xy. So now that we've gathered up the like terms, let's see if we can simplify them. So beginning with the x squared term, negative 8x squared plus 9x squared. Negative 8 plus 9 is 1, so it's just x squared. 6x cubed minus x cubed, that's 6x cubed minus 1x cubed. 6 minus 1 is 5, so plus 5x cubed. And then xy minus xy, well, that's just 0. So our expression simplifies to 8x squared plus 5x cubed. Let's have a look at our last one. This one's a little more difficult. Well, it's not really, but we've got 7ab minus a half bc plus 4ba plus a half cb. Are there any terms there that are alike? Is an AB term the same as a BA term? Does it matter which order you multiply numbers? It actually doesn't. If you think about it, 3 times 2 is equal to 2 times 3. So an AB term is exactly the same as a BA term. So we can actually write it now as 7AB plus 4AB. Could have written it as BA, it didn't really matter. So now when we look at a BC term, is it the same as a CB term? Again, the same pronumerals to exactly the same power, both of those to the power 1. So they're like terms as well, because again, it doesn't matter which order we multiply BC, it's going to be equal to CB. So if you think about it, it's negative a half BC plus a half BC. And of course, negative a half plus a half BC, negative a half BC plus a half BC will be 0. And the whole thing simplifies down to 7AB plus 4AB, 11AB. Now we're going to look at multiplication of algebraic expressions. And this is very similar to what we looked at before when we multiplied out single pronumerals. We've got 3a multiplied by 4b. So it means 3 times A times 4 times B. Multiply the numbers to get 12, and then you've got A multiplied by B. So for the next one, it is 3 times 8 times A times A. Again, remember it doesn't matter which order you multiply in. It's now 24. 3 times 8 is 24. A times A is A squared. For the next one, negative 5mn multiplied, no, sorry, that's positive 5nm multiplied by negative 2m squared n. Let's look at the numbers first. 5 multiplied by negative 2. Then we've got m multiplied by m squared. Notice I've left out the multiplication signs, that's fine. And n multiplied by n. Whoops. N multiplied by n. Okay, even though there are no powers on the single pronumerals, but not the single pronumerals, the pronumerals that don't appear to be a power, each of these pronumerals has a power of 1. It's actually not written there, it's just like the coefficient of 1. It's not actually written, but it's implied. So, put that in there for a reason, we'll talk about it in a minute. Multiplying through now the numbers, 5 times negative 2 is negative 10. M multiplied by m squared is m cubed. And n multiplied by n is n squared. Now that's the answer for that one, but I would like you to show you another way of doing that one. We could have actually done it like this. We could have said it was negative 10 m to the power 1 plus 2, that 1 plus that 2, and n to the power 1 plus 1, that is that 1 plus that 1, to give exactly the same final answer, negative 10 m to the power 3 n to the power 2. I want you to remember that because that's actually the beginning of, or just an introduction to, something that we call the index law. Because another name for powers is an index or an indice. So now let's have a look at our last one. Negative 20d squared multiplied by negative d squared. Looking at the numbers first, and it's negative 20 multiplied by, what's it multiplied by? The coefficient of the d squared, negative d squared, is negative 1. And then we've got d squared multiplied by d squared. The answer is negative 20 multiplied by negative 1 is positive 20. D squared multiplied by d squared is d to the power 4. Or if we wanted to use our index law for multiplication of powers, it would be 20 d to the power 2 plus 2. It's 2 plus 2, that 2 plus 2, and 2 plus 2 is 4, so it's 20 d to the power 4.